What's the difference between AC coupled and DC coupled hybrids, and which configuration should you choose for your solar farm? Solar PV produces DC electricity, which we will show in black. Now, our grid actually runs on AC, so before we can push the electricity from the solar out into the grid, we need to use an inverter, which will change the DC into AC, and then we'll be able to export that into the grid, and now we're showing that AC as green. Similarly to solar, battery storage is also a DC technology. So what that means is that when you have a battery, it also needs to have an inverter before that power can go back into the grid. So in an AC coupled configuration, what happens is that you will have your battery at the same connection point as the solar. The battery will then have its own inverter to change DC into AC, and then you'll be able to put that out into the grid. Now you can see that with this type of AC coupled design, there can be some inefficiencies when you are trying to charge the battery using the on-site solar farm, because what you have to do is go through multiple changes of DC to AC, then AC to DC again. So in order to optimize this efficiency, there is another way that we could design this system, which is called DC coupling. So in a DC coupled system, you will still have your solar array producing DC, and then you've also got the battery, which is a DC technology. Now you'll have a DC to DC converter. And the big difference is that you will be able to utilize one inverter for the whole system, which will then change the combined output of the solar and the battery into AC electricity, which we can put back into the grid. So you can see that now with this design, because we've put the battery behind the same inverter, we are able to be more efficient when we're charging from the solar farm. Because we've also taken out an entire inverter, which is quite an expensive piece of kit, you will also generally find quite material capex cost reductions when you go down this DC coupled route. However, despite the advantages of a DC coupled configuration, there are some trade-offs that you need to consider. When it comes to operating DC coupled hybrids, they do tend to be more complex to operate, and you do lose a bit of flexibility in how you can operate these assets due to the likely path you'll have to take to register the asset with AEMO. The other thing to be aware of is that if you are adding battery storage to an existing solar farm, retrofitting using DC coupling can be very, very complex, or just might not be practical given how the solar farm is already designed. So in most retrofits, we do see that developers tend to go down the AC coupled route, but when it comes to greenfield developments, the DC coupled option is becoming very, very popular. We talk a lot more about battery hybrids, both solar and battery and wind and battery, in our training course on commercial opportunities for battery storage in the NEM. In addition to hybrids, we also cover the evolving revenue streams for batteries, different types of offtake structures, as well as all the latest government policy at both a state and federal level. If you are developing battery assets in 2026, this will be essential for you, and I can't wait to see you there.